Okay, welcome back for video number 5 in the series, I guess, on my earthquake correlation model. And the last one, I think it was 3 days ago, I spent the most of the time just working on new stuff. I thought I'd just go over the list of all the new stuff I've added to it since. I probably should have given an update sooner, because the list is long enough. It's probably going to be a long video. I'll try to rush through it. But you can already see in the menu here all this new extra stuff. So let's see with the list. Yeah, the last video you guys saw all the quakes were the typical USGS orange. So I changed it so then now they're red for the past, green for the future, and because I'm looking plus or minus a fixed number of days. In this case, 3 days. So, 3 days of all quakes within 0.1 degrees, forming a geodesic with the current quake, and then I just cycle through the quakes and look at the data. So, so that's point number 1. The quakes, the arcs as well, are colored green and red. For some weird reason, I usually end up seeing more red arcs than green ones, which I have to check out my algorithm. I would really like it to be symmetric in time, that if a earthquake is touching all these arcs, then I go back in time. I would like to think that means that the previous earthquake would be one of those arcs, and that I would see some more green arcs in the mix. But it doesn't seem to be the case. It seems to be that most of the arcs pointing to the current quake are in the past and not in the future. But maybe don't quote me on that. Don't quote me on that whatsoever. Maybe it's just the case that I'm only going through recent data and I just never happen to scroll back more than 3 days. And I've got a month worth of data loaded, so we can check this really easily. Here's our current quake time, 2025 6/8. So I can easily just scroll back to whenever, like 4 here. And sure enough, let me just correct the statement I just made. There's plenty of green lines as well as red lines. So while it might not be exactly time symmetric, where a quake forms a geodesic and the next quake is on that geodesic, it's at least true that there seems to be an equal number of quakes in the past and the future whenever we look at at a point in time when there's plus or minus 3 days worth of quakes. But yeah, back to the recent quakes and back to the new features. I also got flares in the mix, and flares you're kind of not really going to see them. To plot a flare with this data, it almost doesn't make a lot of sense, because the flare is always going to be, the energy will be coming from the direction of the sun. When it impacts is a different story. What the story is with that. What is it? First the X-rays come, then the electrons come, then the ions come, or something like that. So I at least have the flares there. They are these transparent circles that follow the path of the sun. I just plotted them there to plot them somewhere. I probably should plot them as a time graph at the bottom or something like this. To put them on this map almost doesn't make sense. And at the moment, them being on the map is sort of an awkward thing, because I'm plotting them red for past 3 days worth of flares and green for future 3 days worth of flares, or whatever your window size is. And it seems like more often than not, I'm seeing past flares. Here I just jumped back in time and I showed you, there really are future geodesics. Don't mind me, looking at only data that just happened where we can't see in the future. But here's me doing the same thing with the flare data, and you can see all the transparent circles along the sun's path, the flare data. I only see red, so is that maybe a green one? So maybe I need to just double check my flare renderer. Maybe that's off. I'm constantly working on this, constantly adding features to this, and I'm just showing off the new features with this video. So yeah, flares, arcs, quakes are all now colored based on time. That's one big thing. The next big thing is that I'm adding calculations to this. And the calculations, I'll jump back to the present. The calculations are, we have 4 different contributions of force that I'm considering, which is gravitational. Here's your familiar 9.7 to 9.86, depending on the equator versus the pole. You can select horizontal, vertical, individual components, right? Gravitational, or you can look at tidal forces. And I think I pulled this equation from some kind of linear approximation, Riemann curvature. I got it out of the Gravitation, Misner, Thorne, and Wheeler famous book, but feel free to double check me on the gravitational force magnitude or calculation. I did implement this like a decade ago and do remember calibrating it to something and haven't really checked on the numbers since then. But either way, there's our forces to look at individual components. And once you have your forces, you can also select what planets contribute. So we can see like the gravitational force from the Earth on the Earth, which gives us the old famous 9.8. But you can also look at the gravitational force of the sun on the Earth, and that'll give you, it's incredibly low. Or the moon on the Earth or something like that, which is even lower. Or the tidal force of the sun or the moon on the Earth, which is still pretty darn low. Correct me if I'm wrong, but I'm pretty sure that the tides themselves, their heights is like the second order PDE solution of the tidal force applied to the boundary problem of the ocean or something like this. Correct me if I'm wrong. I've seen the research papers. I haven't implemented it myself, but it's on my to-do list to go over tidal or tide height numerical solutions, but someday. So yeah, you can check out the planet's contributions to each of these things. I'm pretty sure that sun and moon is going to be the most dominant, which is why I usually only have those 2 planets visible here. I wasn't before much of a geometry index guy where I'm thinking that every planet can have magical effects on the Earth. I wasn't before, but the data I will show at the end of the video is kind of compelling to me, but maybe I'm just not a statistician, so maybe I'm looking at things that aren't really there. Feel free to correct me. But nonetheless, we have our force calculations, we have our gravity and tides next on the list. With those forces, you can do like a 2-dimensional cross product on the Earth axis vector, so like the rotation. And what does that give you? I want to say that gives you torque at that point, force cross a moment arm, right? I threw in a 3D cross as well because I don't know. I'm not much of a mechanical engineer sort of guy. I don't exactly know if I'm looking at torque respect to the rotation axis, such that I'm looking at how these forces interplay with the spinning Earth, or I don't know if I'm looking at torque with respect to the vector from the center, such that it might be twisting the Earth off axis. But honestly, I don't think either one. I honestly don't even think the tides or the gravity is influencing things. I honestly think it's something inside the Earth, and that's my next point of data I'm going to throw in the mix is like Earth density, velocity profiles, and those LSVPs that are so trendy in the last few years. And I'm sifting around data sets of that right now. But either way, this is just for humor's sake. We have 2D position, 3D position. I threw in velocity as well, so you can look at the force cross velocity, and you can even combine them just for entertainment. I don't think anything meaningful comes out of that, but this will just apply each 3 calculations on top of each other. Yeah, nothing meaningful. But the one other meaningful thing, speaking of considering like physical quantities here, is that I can also do radial integral in spherical coordinates to the center of the Earth. So you can, if this is like a cross position 3D of all our forces integrated to the center of the Earth, it does look quite a bit different than if you look at just the surface information. Take that how you will. You know, whether you're a fan of, oh, the plates are separate, or whether you're a fan of the material underneath them is going to influence them. Either way, the calculations are there. I'm not sold on them. I'm just looking at them. But let's see, what's next on the list is, oh yeah, then I can also, for these calculations, I can also look at each individual component of them, which, yeah, you can do X, Y, Z in our, I think it's like a Earth-centered frame. Don't quote me on what the name of the frame is. I want to say J2000, but it's not. I'm sure it's not. Maybe it is. Z is the rotation axis. That's all I know. It's like averaged equator. It's whatever the ephemeris 406 data is in. I'm taking that and I'm just recentering it on the Earth and then rotating it according to the Julian day. So yeah, you can look at X, Y, Z. You can look at R theta phi according to the WGS 84 basis. Not spherical coordinates, but with proper ellipsoid consideration. Not yet proper geoid consideration, but I'm looking at that data. I might throw it into the mix soon. You know, who knows? Who knows the limit of what this will be? So yeah, X, Y, Z, R theta phi. You can look at pairs of components, lengths, or angles. If you're looking at the screen right now, you see a bunch of question marks because my poor user interface is IMGUI, which can't seem to handle Unicode, or at least its default fonts can't. So maybe I just need to switch the font, but I'll fix that later. You can deal with the angles, the magnitudes of sets of two components in my WGS basis or the Cartesian whatever basis, or you can just look at the magnitude of all three, which is usually what I keep it set on. So yeah, component display, calculations, integrals, cross products, and that's the calculation side that I've added. I added a DRAP overlay. Let's see if I can get that to work. It just does a remote request and downloads whatever the latest thing at NOAA is at the time of the quake. And usually it's pretty quiet. I don't think any big flares have happened in the last few days. I think that was like a week or two we had the big X-class, a week and a half ago, big X-class flares, and then they all hit Earth a week ago or so. But I can click that button, show DRAP texture, and put it all the way up. And here's our current DRAP at the time of the most recent quake, when the sun was a few degrees prior to the quake. And sure enough, it's lit up where the sun is. You know, like, here, let me just rotate the... Sure enough, the DRAP shows us that the sun is irradiating the Earth like it's supposed to. You know, good job. Nothing special is going on there. I just added it for entertainment just because I always wanted to add DRAP overlay to my Quake simulator. So here it is now. Let me turn that back off. More on the features. Oh yeah, I've added so much stuff since the last time I made this video, but now I've got this drop down of all the different arcs and which ones are closest to our current quake. I want to, and soon hopefully I'll have it so you mouse over and it highlights the arc, but nonetheless you can see how many arcs are within, like, incredibly close, with 2 points incredibly close passing through this third point of our current quake. And it's like I said, my constraints are set to 0.1 degrees here, and it looks like there's a lot, you know. And now you can click on individual ones and jump to those quakes and see that this, you know, one of our 2 points was, oh, big surprise, it was through Ohio, probably Idaho, Stanley, Idaho, like I've been putting in my post for the last few days. Something significant has been shaking in Yellowstone for the last few days, you know. Big surprise there. Let's just jump right back to the latest. And yeah, Columbia. Whoa, that's actually a big one. 6.0, oh my gosh. Hope everyone is all right there. But so there's Columbia. I've dropped down of all the geodesics going through it. That's one of the new things I've added. I've also added info on the planet angles. In fact, let me just change. In the last video, it had the angles to the planets. And if you're a geometry index guy, there you go, you know. tell me, if anyone wants this tool, just tell me, and I will try my best to package it. A detriment to packaging it and putting it out there is the fact that I'm displaying these planets with the ephemeris 406 data. I think that's about 200 or 300 megabytes after I've converted it all to binary and sort of, not really compressed it, but compressed it from its original text, comma, separated value, or whatever format. I think it's downloaded in text, and then you convert it from there. But let me just put all the planets up and just show, a big circle where they are and a small circle at the antipode. And I think I'm getting close to the big reveal for this video, right? So here's the planets I've got. At any given time, I show the 3D angle from the quake to the planet, the 2D angle in just longitude difference. So if you just look straight down on the solar system, straight down from the Earth's rotation axis perspective, and then last we have the angle to the closest touching geodesic. So right now there's 59 geodesics that pass out of this quake and go through two or more other quakes. I should say go through two quakes. 59 that pass out of this one go through two quakes and are within 0.1 degrees of this one. I still need to work on filtering pairs out, but nonetheless, it's pretty. I think it's significant. But this last number here, which I need to put in a proper table, this last number shows you what the angle is from each of our planets to the closest geodesic that it is to, the closest on the list. And what do you know? We have the moon here, which is the gray one here, right here. This is 0.8 degrees from this geodesic. What are the odds? And I'm not a statistician. I think statistics is lies, and that's why I'm a math major, computer science master's, almost 3 times now, almost physics PhD, but it just wasn't meant to be, I guess. I've got some crazy stories of how I got kicked out of 2 of those 3 PhD programs. And it involves money and not my competence. And that's why the stories are crazy. So maybe I'll tell them sometime. But it doesn't involve money. Okay, I should say the first story is just blatant corruption story. The last, most recent story is just, maybe it's a miscommunication. But nonetheless, I probably complained about that last university already in the previous video. Nonetheless, something's always in the way of me and putting my name on a research paper. But either way, most recent quake, moon angle to one of the geodesics, 0.8 degrees. What are the odds? You'll have to tell me what the odds are. I'm not so good at calculating them. Then we go back in time again. Next most recent quake in the Caribbean. And what do you know? Neptune here is 0.3 degrees away from one of the geodesics. Saturn is 0.006 degrees away from one of the geodesics. And those 2 planets, and it looks like 3 geodesics going straight up and down out of them. Look at these quakes that they go through. Look at theirs. Antarctic here, Arctic practically the North Pole here. I want to say that's an atypical thing, but I don't know. But, I should probably put the magnetic field on here. In other news, I've got a WMM World Magnetic Model 2025, 2025. I thought it was the most recent one that they put out. I've got a visualizer for, it's got field lines and where the current field is, and same kind of display, whatever components you want of that. But maybe I will add that to the mix because it's just spherical harmonics, so it's a lot smaller data than the 300 megs, 200 megs or so of ephemeris data. But next quake, in fact, that's right on one of those. It is either right on or it's right beside one of those geodesics I was just talking about. So this is, every video it seems like I highlight the weird geodesic of the day, and today's weird geodesic is this one that just goes straight up and down along South America through the Arctic and Antarctic, it looks like. And there's 2 quakes that are on it. What are the odds? 1, 2, and then the third one, Colombia happened right after that. What are the odds? That's kind of weird. But either way, maybe there's something to this geodesic model method that I'm coming up with. maybe I'm coming up with a method. Maybe I'm not just looking at random correlations. So yeah, this quake happens to be 0.3 degrees from Mars, right? Or one of the geodesics is 0.3 degrees away from Mars, which is this particular geodesic that's going like this through, what, North America, South America? Yeah, Mars here on the geodesic that goes past South America, Pacific side, up through North America, and then down through right past, I guess Mars is right over India right now, right? So that's our closest geodesic for that quake. What are the odds? And then, yeah, go back one more quake, Caribbean again, but Saturn, once again, is 0.2 degrees away from one of the geodesics. And this is my big reveal, is that every single quake that I'm looking at has a planet that's pretty close. I haven't like given numbers. I'm not sticking with like for quakes now. I've stuck it at 0.1 degrees and I'm getting good results. But I haven't really picked a number for planets here. I was never much of a geometry index magic planet angle earthquake correlation guy, but here I threw the numbers in, or the data in, and this is interesting, you know. I'm not putting money on this, you know. I'm not betting on this. I'm not even going to put I don't know. I'm definitely putting my name on it, but I'm not going to say that this is what predicts quakes. But this is definitely a correlation in the quake data, which is what I keep showing week after week, right? Hopefully new things every week. And here, this quake, we have 0.07 from Saturn and 0.26 from Neptune. And everything else is pretty close. And that's the thing, is that when you get, you know, some of these, this guy is touching 7, right? It's touching 7 geodesics. Other ones are touching like 100, right? When you are touching 100 and they all happen to go through Russia, Japan, Alaska, you can get this nice big fan of geodesics, and then you're probably gonna be next to a planet. You know, it's not a given, but it's a likelihood. And let's see if I can see one of those like this. You know, here you have enough lines everywhere that one is bound to be close to your planet. However, it is kind of strange. I think that one happens to be on this weird directly north-south geodesic. But either way, I'm trying to think in terms of stats and what are the odds that this is random versus what are the odds that this is something. And to be completely honest, when I started looking for this, what stood out to me wasn't all planets. In fact, I usually had all the planets turned off, but it was specifically the sun and the moon. I would always keep those on because I was thinking maybe their force or tides or something, gravity force or tidal force was contributing to the earthquakes. And I was looking at these graphs, and then I had noticed that it just so happened that they were always positioned right over a geodesic. And so I thought I'd check the other planets, check all the geodesics, and what do you know? There's always a planet there. But who knows? Maybe that's, in this case, it could just be a byproduct that the geodesics themselves on this particular quake happen to be around the horizon of the solar system plane. So all the planets, of course, they're going to be on it. For other quakes, you know, who knows? Maybe it is. Maybe it's something unique that we're seeing here. What's this guy? I guess 1.2 for Mars is the winner here. And you got 1.0 for Mars. Oh, 1.1 for Saturn. Oh, and Neptune at 0.1. But like I said, those planets are so far out there. I think considering them for earthquake influences is up there with astrology, honestly. But nonetheless, it's nice to look at the data, and who knows, maybe I'll change my mind about the astrology comment. Maybe I will put my name on the fact that these things planet positions correlate with earthquakes or something like that. But nonetheless, what are the odds? 0.4 degrees from Mars. Once again, look, Mars is causing some significant quakes lately. What are the odds? Oh, twice in a row even. Twice in a row. And then 0.7 for Jupiter, 0.8 for Pluto. Oh, even better, 0.1 for Venus, 0.4 for Mercury. Wow, this is one of those fan patterns I just mentioned through the very same locations I just mentioned, Russia, Japan, Alaska. Basically any quake that's going to strike America right now, because it's just so covered in quakes at the moment, is going to create a fan of geodesics, which is probably going to pass through most things, but still, nonetheless, what are the odds? Yep, Mercury 0.7, Pluto 0.45, way out there, not even a real planet, still making earthquakes. What are the odds? Okay, I've talked too much. There's my big reveal. I think I've shown everything I want to show. Thanks for watching. Like, share, and subscribe. Whatever. Bye.